Right, hello. Yeah, there is a text version of this talk at that QR code if the audio is crap. Um, right, I'm Kliment, and I'm here to talk to you about KiCad and its libraries and how to not burn out people who contribute to open source. I may also rant a bit about standards. So KiCad is an open source and free software application for designing electronics. You may have heard of it. The canonical name is KiCad and not KiCad for reasons. There's a long argument. I won't get into that. Lots and lots of people use KiCad. To the best of our knowledge, it's the most popular electronics design tool in the world. We don't spy on our users, so we don't have exact numbers, but we know that multiple hundreds of thousands of users download every new release. And this doesn't count downloads from Linux distributions and such, so there's likely more. And there's several PCB manufacturers who have said that KiCad is now the most frequent software they see boards designed in. So that's nice. And each KiCad installation contains a set of part libraries, and they get shipped to every user. And these libraries are, as far as we know, the biggest open collection of electronic components. They contain over 22,000 schematic symbols, over 14,000 footprints, over 6,800 3D models. If you're not familiar with those terms, a symbol is the abstract representation of a component that goes into a schematic, and the footprint is the representation of the area of the actual circuit board that the part occupies. So open libraries, open in this case means open license and open development. So our license is Creative Commons attribution share alike, with an exception that any part that is used in an actual design may be relicensed under whatever license the design itself has. And the development of the libraries happens in a public Git repository, which users can directly contribute to. So the problem with this is the parts in these libraries end up in thousands and thousands of designs every day. And we have goals for our libraries. We want the parts in there to be correct, useful, and consistent. We don't try to aim for completeness, as we can't possibly keep up with the industries, but all these parts should be good enough for people to use as they are without having to double check everything. And they should lead to readable schematics and be reasonably interchangeable with similar parts. Most of our library comes from user contributions. And hundreds of people contribute, some just once, others have made tens of contributions. Some parts have been in libraries for decades, but many are recent as the libraries grow very rapidly with the user base. And as more and more people use KiCad, more of them contribute to the libraries. And this is a good thing. It's really great that people are actually contributing back. However, before releasing a contribution to the user base, it needs to be checked for correctness, usability, and consistency. So I'm part of a small group of volunteers that sits at the intersection between the hundreds of contributors and the hundreds of thousands of users of KiCad. We're the KiCad librarians. So we maintain the libraries in what would otherwise be our free time. We've messed up a number of things in the past, and each time we decided to not let that happen again and put measures in place to help us keep to that commitment. I'd like to tell you what that's like. So every day, a few contributions trickle in. They currently average around 200 per month, and they never, ever stop. This kind of thing really messes with your mind as a volunteer reviewer, because the work is never done. The more efficiently you process contributions, the more this encourages contributors to contribute, and the more ambitious their contributions get, which is awesome, but it's more work for reviewers. A typical review can take anywhere from a few minutes to a few hours, and some enormous contributions affecting hundreds of parts can take months of intermittent effort to review. So what you do, you take a few days off, and the number in the queue goes up. Then you spend a few hours on reviews, and the number goes down a bit, but so does your energy level. And the next day, they're back with more. And if we don't keep up with reviewing them, they pile up. This creates problems. So our contributors get discouraged by long processing times. The contributions themselves go stale and need to be updated and need more work to handle. And librarians feel under constant pressure and eventually burn out. This leaves the remaining librarians with a bigger load, so they also burn out. And eventually everyone's burned out, contributions pile up without any limit, contributors get frustrated and stop contributing, and progress slows down to zero. this happened. It was awful. So we ended up with a large pile of over 1,500 mostly stale contributions and very little librarian energy left to deal with them. And we decided to not let this happen again. So this is a social problem, fundamentally, and the most effective solutions are social in nature. However, we also have a surprising amount of technology we use to help. Fundamental problem here is we have more contributions than reviewer bandwidth, as in lots and lots of people want to make KiCad's libraries better. And if you state it like that, it's not a problem. This is a great thing. This is exactly what we want. These are people who are enthusiastic about contributing and putting in time to help. So the obvious solution is to recruit some of them to be librarians. And we did that. We started with empowering contributors who had been active for many years. And then we moved on to recruiting enthusiastic newcomers as well. So when we noticed a contributor putting in lots of effort into contributions, we'd approach them and ask if they wanted to join. Hey, you seem to be putting lots of time and effort into making KiCad better. Would you like to use some of that time and effort to help reviews? And some of them say yes. So we had to develop a training curriculum for new librarians. And I had the pleasure of doing the onboarding for most of them. We put together some documentation and checklists and process notes on our wiki so that the oral knowledge held by a handful of people would not be lost. And eventually we got a reasonable sized group of people. So then we had to make sure it doesn't happen again, so we didn't burn them out again. So we introduced our policy of zero pressure. So it's expected and normal for a librarian to disappear and not do anything for months at a time. We aim to have enough librarians that there's no pressure on any individual one of us to do something. We also have a policy where even if one of us has started to work on something, they can still go away when it gets to be too much, and someone else will eventually take care of it. This change alone has dramatically improved our productivity and recruiting success because it enables people with intermittent availability due to work, life, and health to still contribute when they're able and motivated. And it turns out when people are not expected to keep up a constant level of performance, they can have bursts of extremely high productivity. Occasionally, those moments coincide for multiple librarians, and we get ridiculous amounts of things done. People will drop out over time, and that's fine. We keep recruiting more librarians, and we never blame people for dropping out. And this makes it easy for them to come back if and when they feel like it. We decided the health and motivation of the library team is more important than the metrics, like the size of the queue or contributions processed. And when we did that, the metrics actually improved as well. So our median response time from submission to first review went from months to days. We also have and use a lot of technology to help us handle reviews faster and easier. Our libraries currently live on GitLab, which, while it has lots of issues related to being an American megacorp and infected by AI hype, has been a really good home for KiCad and the KiCad libraries, as long as we diligently turn off all the LLM functionality everywhere it's hidden. We manage our libraries as Git repositories, and contributions to them come in the form of GitLab merge requests. We use lots of GitLab features to make our lives easier. So we use CI pipelines for automated checks. We deploy custom review tools. We use metrics and test reporting to understand the impact of a change. And we also have lots of custom tools. Many of those actually came from external contributors, some from us, and some from external contributors who later joined us as librarians. Our libraries have a long history. There have been parts of variable quality in there, some broken, unusable, or dangerous. For example, some parts use the KiCad feature that will silently connect power supplies together, leading to damaged ports. Many parts were included very early on and never checked since and contained errors, and some of them are still lurking in there yet to be found. So at one stage, libraries grew to a point where we decided to have standards that library contributions should meet for inclusion, and that we should actively prevent footguns. And this resulted in the KiCad Library Convention. So the KLC is a set of guidelines for various aspects of library parts that defines criteria for what good parts are. It's specifically not a set of rules in the sense that every KLC guideline can be broken if doing so makes the library better. And they look something like this. So here's the rule for courtyards, for example. Yeah, we have a lot of code to automatically analyze contributions and check for compliance with these guidelines, and to show any suspected violations to the contributor before it's ever been reviewed by a human librarian. And this helps a lot, especially as these automated checks are really good at checking subtle errors that are difficult to see in human review. When we find something problematic in parts of the library, or frequently missed mistake, we can put in code to check all new contributions and existing library parts for that specific mistake. So why do we need our own customized KOC as opposed to using industry standards? Well, first of all, we have to make policy specific to KiCad as an application, how it's used. But also, and this is a bit of a rant, there are major problems with industry standards. So the most relevant standards organization for electronics is IPC. And we rely heavily on the IPC 7351 and 52 series of standards. However, these standards are poorly written. They contain errors, they contain omissions and internal contradictions. 7352 partially supersedes 7351 and has contradictory guidance to it. And the fundamental problem behind this, and I can't go into too much detail because of time constraints, but I can rant about this all day. So the fundamental problem behind this is how IPC operates. They are nominally a non-profit with industry membership, but their entire operational budget depends on them being able to effectively prevent access to information from everyone who hasn't paid. And this incentivizes them to aggressively prevent knowledge sharing, even within organizations, because they're charging per seat, and to fragment knowledge across as many individually built documents as possible with unnecessary references and incomplete documentations. Each document costs triple digits to access per person and may not be shared in any form. I'd like to show you examples of editorial issues, but there are terms preventing from doing so. I don't want to single out IPC here as a bad actor. This is not specific to them. Many standards organizations work the same way. And given the economic benefits to the industry and wider society from complying with standards are much, much bigger than the budgets that these organizations work with. Instead of funding collectively and opening the results to everyone, the industry decided to introduce additional barriers to compliance. And we see the results of this directly in our work. So vendors come up with their own slightly incompatible variants of standardized parts, and we have to put in extra effort to keep up. This is the cost of closed knowledge. Rant over. Right, yeah, we occasionally need to do major rework to fix issues, to incorporate design approach changes, or to make things more consistent. For example, because a standards organization unexpectedly changed their mind after sticking to an unpopular change for years. When that happens, a lot of parts change, and it's difficult to review them. KiCad is not really good at this kind of task, where a large set of parts are being compared to each other in before and after revisions. So to handle this, we built some tools to make it possible to quickly view large sets of changes from the contribution itself. So this is a web-based interface that lets us see what parts have changed and then rapidly scroll through a large number of them and see changes to the visual representation of the part, its code representation, its metadata and elements. We have this for both symbols and footprints. And this, again, was contributed by an enthusiastic user who later joined the library team. Once we had these tools in place, we started to use them not only for reviewing enormous changes to hundreds of parts, but for almost every contribution, because they let us see changes and check parts at a glance, speeding up what would otherwise be a much slower process locally with KiCad. This is a pattern we keep seeing. The tools that made the complex reviews viable at all make the less complex reviews faster as a side effect. Another tool we use heavily are generators. These are Python scripts that output KiCad parts without anyone having to manually draw them in the application. The vast majority of the footprints in KiCad, over 11,000 of the 14,000 we have, as well as the majority of 3D models, are generated by code from data. And this dramatically simplifies reviews, as we only need to check the data and not measure every single dimension. This also enables us to make sweeping changes that are still viable to review and to maintain parts across changes to KiCad formats by regenerating them as needed. We can generate most footprints, many 3D models, and some symbols. This is mostly Python code. It's written by librarians and contributors. And the 3D generators use cat query as a backend, which, by the way, is awesome. So generators also make life easier for contributors because they know that anything coming out of the generator meets all the baseline requirements. And the only thing that they need to make sure of is the correctness of the data. If something is wrong with the generators, we can fix that in one place for all of them instead of having to fix each individual output part. And finally, we put some automated testing in place, not only for compliance with our conventions, but also to check for unintended changes and to verify any changes to a generator have not broken other generators. This has let us make changes more confidently and avoid breaking things. So has it helped? Metrics say yes. We've not had any backlog increase in the past few years. Our backlog drops by about 200 contributions per year. And this is happening despite the contribution volume increasing significantly every year. So between KiCad version 8 and 9, we processed over 2,200 contributions, which is more than twice the size of our remaining backlog. And there's certainly many more active librarians now, and everyone on the team, whether they've freshly joined or a long-term contributor now made official, have been absolutely awesome. Our median contribution processing times have gone from months to days, and this is super motivating to contributors. New users still complain about the libraries and about our processing times, and we can still do better. However, anyone who's used any other parts library, particularly the automatically generated ones frequently linked by vendors and distributors, notices that the official KiCad libraries are of significantly better quality because of human review. And many tell us this. Psychologically, it still feels like an uphill struggle. No matter how much work we put in, it's never done. And new contributions keep coming in, and there's always more maintenance tasks to do. But if you look back over several years of progress, the improvements are very visible, and I think we're doing the right thing. Most importantly, I feel we now have more of a socially cohesive librarian community who are there for each other. That said, we're always looking for new librarians. If you want to join us, we'll provide training, support, friendship, and endless things to do. Yeah, so yeah, this is my email. This is our wiki. Yeah, we very much welcome new contributors and librarians. And I guess I don't have any time for questions. All right, yeah.